This lesson we'll be looking at some applications involving parabolas. So we'll just work through one question. A piece of wire measuring 100 centimeters in length is bent into the shape of a rectangle. Let x centimeters be the width of the rectangle. Now, sometimes with these application questions, it can be helpful to draw a diagram. Not always, but if the question lends itself to one, then it can be really helpful to draw a diagram. So let's draw up a rectangle. We know the perimeter of this rectangle is 100. We know x is the width of the rectangle, so this will be x, and this will be x as well, so we can leave that out. X centimeters, and we know that these two lengths here will be the same as well. Alrighty, let's have a look at part A. Part A says use the perimeter to write an expression for the length of the rectangle in terms of x. So let's just start by labeling the length L. We know that 2 times L, so L plus 2 times x is going to be equal to 100. That's just the perimeter. X plus x gives us 2x, plus L gives us 2L. That adds up to 100. Now we're trying to write an expression for the length of the rectangle in terms of x. So in other words, we want L to be the subject of this. So let's make that 2L equals 100 minus 2x. Divide everything by 2, L equals 50 minus x. So we've got an expression for the length in terms of x. That's part A. Let's have a look at part B. Part B says write an equation for the area of the rectangle in terms of x. Now, we know the area of the rectangle is going to be x, so the width, times the length, and we know our length is 50 minus x. We just found that in part A. So that's part B. We've written an equation for the area of the rectangle in terms of x. Let's have a look at part C. Part C says decide on the suitable values of x. Now, we know that length and width both have to be positive. So in other words, our length, which is 50 minus x, has to be greater than 0. The length has to be positive, and as does the width. Our width was x, so we know that x has to be greater than 0 as well. Let's rearrange this here, which will give us x has to be less than 50, and this one will just stay as is, and x greater than 0. So in other words, x is between, you can leave it like that, that's fine if you leave it like that, but a simpler way of writing is actually just to say that x is between 0 and 50. So x is greater than 0 and it's less than 50. So those are the values that x can take. Let's keep going with part D. Part D says, sketch the graph of A versus X for suitable values of X. So I've got my Cartesian plane here. Now, keep in mind that our parabola has a subject of A. In the past, most of the parabolas we've dealt with have had a subject of y equals x outside of 50 minus x. Here our subject is a, so our vertical axis we need to label as a rather than y, a representing the area. And then our horizontal axis just stays as x. Now we just found that x can be between 0 and 50. So we've got 0 here, 50 over here. Let's go ahead before we sketch this and find our turning point. So hopefully you're getting confident with this process. Now to find the turning point, find our axis of symmetry, First, the axis of symmetry will lie halfway between our x-intercepts. So these are our x-intercepts here, 0 and 50. So axis of symmetry will be x equals 0 plus 50 over 2, which equals 25. When x equals 25, a equals, let's go back to our rule, a was x outside of 50 minus x, so 25 outside of 50 minus 25, which gives us 25 times 25, which gives us 625. So we know our turning point is at 25, 625. So our turning point will be here and at 625. So let's go ahead and sketch that. Turning point 25, 625. Alrighty, let's move on to part E. Part E is asking us, use the graph to determine the maximum area that can be formed. Now, the maximum area that can be formed can just be found by looking at the maximum, so in other words, the turning point on the parabola that we've sketched. The maximum area is just going to be this maximum point here, our turning point. And the maximum area based on the graph is 625 centimeters squared we're working with. Max area is 625 centimeters squared. Alrighty, last section. Part F is asking us what will be the dimensions of the rectangle to achieve its maximum area. So we need to take note that the maximum area occurs when x is equal to 25. So our maximum area of 625, that occurs when x is equal to 25. So max area occurs when x equals 25. So all we need to do is substitute in x equals 25 into our rule for the length. So length equals 50 minus x. Remember, the question's asking us to find the dimensions of the rectangle to find the maximum area. Our x was the width and our length was equal to 50 minus x. So L equals 50 minus 25. So L equals 25 centimeters. Therefore, the dimensions, remember x represented the width. So our width is 25 and our length is 25. Width of 25 centimeters and length of 25 centimeters will give the max area.